Oh dear. Here we go. Quick refresh, pray the Wi-Fi works. Wi-Fi works, brilliant. Right, okay, so my name is Chris Price, and I'm going to be talking to you today about machine learning in JavaScript. So I'm going to quickly cover what it is, what it can do, how it works, and our experience of basically whether you should be using it. So hands up, who's used TensorFlow before? Who's heard of TensorFlow? Great. All right. Just for the folk who haven't, TensorFlow is probably the library that powers the vast majority of the AI or machine learning experiments you'll have heard of. It's created by Google. And the reason I'm stood here talking about it now is that they now have a JavaScript version. And this JavaScript version has two main features. One is it lets you run pre-trained models. So it lets you run something like MobileNet, PoseNet. Sorry, we'll come back to MobileNet. That's why I'm skipping over it. PoseNet, if you remember the Kinect on the Xbox, PoseNet basically lets you do that just with a webcam. Cocoa SSD, speech commands, lots of other pre-trained networks, all available for you to download from the web, or NPM, I guess. Or you can make your own. So you can pre-train a model on the server side, and then you can download it into the browser and run it there. But I guess the other side of machine learning, it's all well and good running models, but an interesting part of it is always training new models as well. So they're the two main features of TensorFlow, but demos are always more exciting than anything else. Oh, that's Paul's face. Apologies for that. This, again, no more brand placement. This was the first mug that I came across in the office. And I should explain that that image is being fed into MobileNet. And the output of MobileNet, which is 1,000 different categories, and the relative strength that MobileNet thinks that the image that you're feeding it belongs to one of those 1,000 different categories. So each of those 1,000 categories is represented by a dot. The size of that dot represents the likelihood that MobileNet thinks it is that category. So here you can see that it's very strongly hinting that it's a coffee mug. This initializes randomly, so apologies for the poor position. But it's very confident it's a coffee mug. It thinks it could be a water jug or a bucket or a cup, but it's nailed it with coffee cup, which is hopefully, that was one of the things it was trained on. That's one of the categories it was trained on. That's good. It should get that. Now this represents an example where it's kind of got the wrong thing. So does anyone recognize what that is in the background? The guy who sits next to me at work. So that sits on my desk. It's a Lumetric clock. And I guess if you didn't know what it was, you would probably have described it as a digital clock as well, or potentially a scoreboard or something like that. So you can see kind of MobileNet, when it doesn't know what something is, it behaves quite similar to the way that you would. That picture shares lots of characteristics with those things. So let's show it another thing that it doesn't know. This time it's an absolutely terrible picture of an iPad, but again, MobileNet doesn't know what an iPad is. It knows what an iPod is, so it's guessed it might be something to do with Apple. I don't know how it's got that, but it's basically something with a screen. So you can see it still gives you a rough answer, even if it doesn't have a clue what it's looking at. But sometimes it gets it wrong, and I preface that because it can do it live, and normally it comes up, there we go, shower cap, very flattering. But I'll type bow tie instead. We'll focus on that. So one of the big features of MobileNet is that it is optimized to run very fast, and it can run on your browser or run on mobile. So jumping back. Why have Google done this? Why have they ported it to JavaScript? Well, to paraphrase someone who shared the Fin.js stage before, why not? I guess equally with kind of when Larry was saying if you choose a language based upon the frameworks that are available, equally you probably choose frameworks based upon the language that you're using. So porting TensorFlow to JavaScript is a natural fit. And it's a big step out of the data science lab. So if JavaScript has taken over the world, if AI is going to take over the world, then it's kind of got to be put in the hands of the developers of the most ubiquitous platform out there. And an interesting angle to it is that it starts to allow machine learning with optional cloud. So machine learning with optional cloud means you keep all of the data local to the device, which is an interesting thing because people maybe are starting to get concerned about uploading all their data to big technology companies. How? Your bladders will probably be glad that I'm not going to explain it in extreme detail here. Suffice to say that machine learning is all about crunching numbers very, very quickly. And in order to do that in the browser, Tensorflow.js uses the model. It takes the model and it compiles down the operations that the model wants to perform into shaders. Those shaders are then ran on your GPU, and they're ran using WebGL. But that works really well for running the models, and you saw MobileNet running there very fast. But maybe there's a question on your mind. So it's all well and good being able to take a model and run it. But if you want to train a model, everyone knows that training machine learning models takes hours on really specialist hardware. So no user is going to be happy if you lock up their browser for 2 or 3 hours while you do some training. So how can we get around this? How can you actually use training in the browser? Is there a way? Well, first off, does everyone know what training is? I guess this is kind of a bit of a visual montage of a typical training setup. But again, at a high level, I prefer to think things like this. So yeah, all that stirring does take an awful long time. So how can we optimize how long the stirring takes? Well, we can use a technique called transfer learning. And transfer learning allows us to take a pre-trained model, in this case MobileNet, and capitalize on all the training that's gone into it. So we take 95, 99% of MobileNet, we chop the end off, and then we replace the end with our own custom network. That custom network, because of the way the maths works out, we'll be able to train in seconds as opposed to hours, which is something a user will put up with, hopefully. I'll be back in a second. Everyone remembers pit trading, right? So this is an example of pit trading, lots of hand signals, lots of very angry-looking people shouting at each other and gesticulating wildly. So I'm going to run a demo now, and I'm going to take you back in time. And we're going to pretend that JavaScript existed in the 80s, 90s, noughties, and it was as popular as it is now, and TensorFlow.js existed back then. And we're going to build a program to interpret the gestures that the traders are using, but we're going to use a program because we don't want to deal with them directly because they look a bit frightening. So let's jump over to the demo. Ditch my face for a second. Okay. So in this demo, if it works, so demo god's on my side, what we're going to do is we're going to run through a training exercise. So it's important to note that this is going to be a model that has never been trained before. Oh, there we go. So now we're going to feed it with lots of sample data which represents the 2 motions that I can perform, or the 2 gestures I can perform. So one is going long, and one's going short. There we go. Now it's important to capture quite a few different images because you need representative images so that when I pull something, when I panic in the midst of all my trading later, it still roughly works. So there we go. Hopefully I didn't mess that up. There's a training montage. Right, so let's give it a whirl. So at the top, it should say long when I hold my hands up like that, and it should say short when I hold my hands up like that. Woo, oh, woo, ah. Right, let's give it one more turn. Right, I think I messed up in the middle. Right, we'll go long again. And then we go short. And I'll do it for the entire duration this time. And we'll go long again. go short. And then we go long. Didn't feel so slow beforehand. Okay, training montage again. Right, short. Oh, come on. Oh, that's long. That is right. Well done it. Short. Yeah, there we go. Long, short. There we go. Right. Whew. So now we're going to do some trading. The price graph is going to tick in from the right. I make money if I'm long and it goes up, and I lose money if I'm long and it goes down. Conversely, if it goes down and I'm short, I make money. This is the best I've ever done. Anyone who's at FinJS New York knows this is not what normally happens. Wow, okay. This is good, this is good. Oh, shoot, no, that's not good. Come on, come on, come on, come on. Come on, is it going to tip? It's going to tip. No, no, no. There we go. That's so much better than I normally do. There we go. I made the top score. Yes, live on stage. There we go. I'll take that. Cool. So, all right, at the risk of infuriating the demo gods more, can I have a volunteer from the audience, please? Come on. Mitra. Right. Okay, sorry. There we go. Important to get the trading jacket on. Right, so if it works, I remember my clicker this time, so I should be able to tick it on. So, yeah, that's the one. Hands away. If you try and keep your whole hand on the screen, yeah. That's it, and flip them around. Cool. And the other way. And back again. And finally, I think. Cool. All right, we'll find out what it does. Okay, so long should be, yeah, that's long, and then short's the other way around. Get in. Right. Don't test it too much. All right, so we're going in the trading game again. So if you think it's going to go down, you want to go short, so palms forward. If you think it's going to go up, you want to go palms towards you. Right. Okay, counting in. 3, 2, 1, go. All right, oh, it's on. I can't remember what I got. I think it was 1.8 million, so that's when we need to cheer or boo. What do people think it's going to do? Do people think it's going to be higher? Or, here we go. Oh no, it's getting dangerously close. Oh no. Here we go. It's got it. Oh no. Oh, you nailed it. Thank you. Thank you very much. Sorry? You did. You did. Oh, so yeah, you need to put your name in. But, there you go. Top of the board. Top of the board. So, that was a silly demo. But I guess it was built on kind of our experience of playing around with TensorFlow JS. And that was, it was inspired by a conference talk about 6 months ago. We had some of our interns play with TensorFlow JS over the summer. And this is what they built. It's the little bit in the, I've got a mouse cursor, the back there. And you show up items from our tuck shop, and it recognizes the item and then lets you pay for it instead of having to get your phone out or pay on your phone, that kind of jazz. So, the good news, it worked, like my second and third demo. So it's kind of able to achieve about 95% accuracy, which is good enough for us, and it's enough to keep people using it, which is a big success factor for us. The bad news was, though, it was a much rougher experience to play with it than we expected. It felt to me a lot like going back to the dark days of web development. There's lots of cross-device problems, and if anyone who's played with kind of WebGL or push WebGL before, like this library does, you really run into memory management issues, which makes it quite tricky to use and something I'd be cautious about using in production. However, the ugly side, and I should hasten to add, I'm not talking about our interns. This capturing training data for any kind of machine learning in this ilk is painful. It always has been painful. It always kind of will be painful, I guess. So yeah, training data is hard to come by. Don't underestimate that if you're ever going to play with it. So, in conclusion, machine learning is becoming ever more accessible. It's something that's there and very easy to play with. So check it out. But collecting training data is still incredibly hard. And the device support is a bit limited or certainly patchy. Thank you.